All right, today we're going to start a new section, a new unit, and we're going to look at different types of thinking. In that first unit, we learned how to name points, lines, planes, rays, angles, etc., all different types of geometric figures. Now we're going to start looking at how to think a little more geometrically. In algebra, it's very straightforward. You're going from one step to the second step to the third step. In geometry, it's very different. You have different ways to get around a problem to get to the same conclusion. And we're going to start looking at ways that we can think that way. And the first way is called inductive reasoning. And all that inductive reasoning is the process of observing data, recognizing patterns, and making generalizations about those patterns. Now, if you need to, pause it to take that down. But inductive reasoning is just making patterns. That assignment that you received after the test was just practicing on making patterns. Just kind of a little bit of a review / introduction to this unit. A conjecture, we talked about what a postulate was earlier. A conjecture is where we use inductive reasoning to make a generalization. And a conjecture is something that's been proven over and over and over and over again, so it has to be true. All right, this investigation, I'm not going to spend a whole lot of time on this. Pause it. I want you to spend a little bit of time looking at these things. But I want you to use inductive reasoning to draw the next two figures. I want you to draw the 25th figure and the 30th figure as well, and be prepared to talk about this in class. I'm not going to give you the answers right now. I'm going to continue going on with the rest of my notes. Pause it until you're able to figure out what the next couple of figures are, the 25th and 30th, and then we'll talk about those in class. After you figure those things out, then continue with the rest of the video. All right, mathematical models. This is something that you should have covered at the very beginning of algebra. We're going to use inductive reasoning to find a pattern in a sequence of numbers, because that's really what math is all about. It's finding patterns and using those patterns to help us solve problems. And this the function rule is used to determine the nth term of a sequence. And this should hopefully look very familiar to what you did in algebra. We'll briefly review. I've got a lot of examples on here. I'm not going to go through every single example, but I will go through a couple of them. If you have questions in class, I will save some of those examples to do in class. All right, so this first one, I've given you basically everything that you need. I've given you what the term, because the n is always the term number. So let me write that here. And I'll just use a symbol for number so it don't take me forever to write it. So this n is the term number. Okay, that's all that means whenever you hear that. This n minus 5, this lets us know what the actual number is in that sequence. Okay, what the value is. So if I take the term number and I plug it in for n, it gives me this term. Okay, so that's kind of like your input and your output. You can kind of think of it that way. Okay, so if I do 1 minus 5, I get negative 4. 2 minus 5 is negative 3. 3 minus 5 is negative 2. And we'll quickly finish filling out this table. So 4 minus 5 is negative 1. 5 minus 5 is 0. 6 minus 5 is 1. 7 minus 5 is 2. And 8 minus 5 is 3. Okay, so let's talk about where these numbers come from. So I'm going to look at my terms down here. So if I go from negative 4 to negative 3, that change is 1. Negative 3 to negative 2, change is 1. Negative 2 to negative 1, change is 1. Notice the pattern, we got everything as a change of 1 here. Well, if you have just a variable and there's nothing in front of it, it's really understood to be a 1. So this change that we have here is actually the number that goes in front of our term number. And this minus 5 would be where our pattern starts if we had a space in our table that was 0. Because if this went negative 1, negative 2, negative 3, negative 4, if I had one more term in front of it, it would be negative 5. And that's where that comes from in our equation. Okay, so let's see if that holds up for this other example. So I'm going to plug in 1 for n. So 1 times 4 is 4. 4 minus 3 is 1. 2 times 4 is 8. Minus 3 is 5. 3 times 4 is 12. Minus 3 is 9. 4 times 4 is 16, minus 3 is 13. 5 times 4 is 20, minus 3 is 17. 6 times 4 is 24, minus 3 is 21. And let's just go ahead and finish filling out our table here. 7 times 4 is 28, minus 3 is 25. And 8 times 4 is 32, minus 3 is 29. Okay, again, so let's kind of figure out where these numbers come from. If I'm going from 1 to 5, that's 4. 4 to 5, 5 to 9, I'm sorry, is 4. 9 to 13 is 4. 13 to 17 is 4, and so on and so forth. Each one goes up by 4. So that 4, that change, is the same value that's in front of our n. And if I were to continue that pattern for 0, I would have to go, instead of up 4, I'm going down 4. Well, there's that negative 3 from our equation. Okay, so that's where that pattern comes from. And that's all an equation is. It's just a pattern based on the numbers that were given, and that's inductive reasoning. Okay, so these next 3 examples, I'm going to save these for class. If we'd like to see them again, just let me know and we'll go over these 3 together. Okay, so now this time I did not give you what the expression is going to be. We're going to figure that out together. Okay, so I've given you the term number up top, 1, 2, 3, 4, 5, 6, 7, so it's going up by 1, and I've given you the value. So let's come up with an expression for n. Okay, so first thing I'm going to look at and see is how do these change. 20 to 27, it goes up by 7. 27 to 34, it goes up by 7. 34 to 41, 7. Starting to notice a pattern, 7. Again, that's all that math is just patterns. The faster you see the pattern, the easier math is. All right, so each one went up 7. So that means my expression is going to be 7n. That's it, just 7n. So now this pattern has to start somewhere. So I want to know where it's at when my term number is 0. So if each one's going up 7, if I'm at 20, that means I need to go backwards and go down 7, and we've got 13. So now I can plug this in. So 7n plus 13. Now in class, I'm also going to show you a way to check your answers in the calculator in case that you've forgotten. So I will show you that in class. Okay, so 7n plus 13. All right, let's look at one more example like that, and then that will be it for this video. All right, so again, look, I'm looking here. First thing I want to see is make sure that my term goes up by the same amount. So 1, 2, 3, 4, 5, 6. Perfect. So now I'm going from 7 to 2. That's going down by 5. 2 to negative 3. That's going down by 5. Negative 3 to 8. Again, down by 5. So we've got our pattern. Each one's going down by 5. So my expression is going to be negative 5n. I know that it has to be that part. Well, I got to figure out what I have to add or subtract to it. So again, I want it when the term is 0. So since I was subtracting 5 going this way, going back to the left, I'm adding 5. So 7 plus 5 is 12. So my expression is going to be negative 5n plus 12. Okay. All right, so that's it for the video. Very short and sweet. Just looking at making patterns, using those patterns to come up with expressions and equations. And again, that's all math is finding those patterns. Okay, and that's it for the video for tonight.